Okay, so here are the homework solutions. So the first two problems are centered at the origin. And what we're looking for is the center. So the center in this case is 0, 0, because you just have x squared and y squared. The vertices, so the first thing you have, before we find the vertices, let's talk about whether it's a vertical transverse axis or a horizontal. Well, because x squared is positive, it has a horizontal transverse axis. And A, which goes with the transverse axis, is 3, and B, which goes with the other axis, is 5. So we take the square root of 9 and the square root of 25. So we know c squared is equal to a squared plus b squared for hyperbolas. So that's 9 plus 25, which is 34. So c is equal to the square root of 34. And the square root of 34 is 5.8. Okay, so let's plot it, and then we'll come back and define all these things that are going on here. But we just need to plot it first. And I think we can use the standard scaling on this graph. So this is 10 as shown. Okay, so the first thing we do is plot the center. Now we have a horizontal transverse axis, so that means we go horizontally 3 units. 1, 2, 3. So that's one vertex. 1, 2, 3. That's the other vertex. B, you go the other direction. So 1, 2, 3, 4, 5 up here. 1, 2, 3, 4, 5 down there. And the foci are along the transverse axis 5.8. 1, 2, 3, 4, 5.8 this way. 1, 2, 3, 4, 5.8 that way. And so we draw our box. Like that. Okay, so what do we need to know? Vertices. So the vertices, those are the red things. And those points are going to be -3, 0 and +3, 0. So those are those 2 points. You go from the center to the left 3, center to the right 3. The foci are also along the x-axis, so y is 0 for both of those. And c is 5.8, so we go plus 5.8 and minus 5.8. Now the equations for the asymptotes, so there you have that one, and you have that one. Now I'm going to show you how to use the formulas. So there were two formulas for the equations for the asymptotes, and one was for horizontal transverse axis and one was for vertical. In this case we have a horizontal, and if you go and look at your notes or go to the book, you'll find out the asymptote equations are k plus or minus b over a times x minus h. So that's for a horizontal. In our case, h equals 0, k equals 0, A is equal to 3 and B is equal to 5. So what we end up with is y is equal to 0 plus or minus 5/3 times x minus 0, or y equals plus or minus 5/3 x. So anytime you have a hyperbola that's centered at the origin, you just have a simple proportion. And that's how you would do it otherwise. So if you think about it, I go through the origin. So if I think about y equals mx plus b, slope-intercept form, you can see the y-intercept for both of these is going to be 0. And then all we need to figure out is what the slope of these lines are. So you'd have 1, 2, 3, 4, 5 vertical, 3 horizontal. So that would be y is equal to 5/3 x. And if you take this one, you go down 5. 1, 2, 3, 4, 5 over 3. So it's negative 5/3 slope times x, which is the same one you got from plugging into the formulas. And then what does this thing look like? So you start at the vertex, you go outward towards the asymptotes, but you never cross the asymptotes. Same way here. I'm going to start at the asymptote, go to the vertex. You can go either way. The key thing is to go through the vertex and to not cross the asymptote lines. The rest of it's kind of, up to you to see what's going on. Okay, so that's number 1. Now you'll notice I flip back and forth here so we can cover both horizontal and vertical transverse axes. So number 2, again, the center is the origin, not just because the problem statement says so. Actually, this doesn't say so. This one, later it does say so. In this case, it doesn't say so. But because we're not subtracting anything from x or y, the center is the origin. A always goes with the positive term. So A is the square root of 16 and B is the square root of 4. Now because y is positive, we have a vertical transverse axis. So what we're going to have is, we're going to have some kind of vertical arrangement. The vertices will go up and down in the y direction, and the focal points will be a little bit farther outside of that. So we do need C because they asked for the foci, and what they're asking for is the coordinates. So remember, c squared equals a squared plus b squared for a hyperbola. So that's 16 plus 4. 16 plus 4 is 20. So B is equal to, or C is equal to the square root of 20. And the square root of 20 is 4.5, rounded off. And we just need 2 decimal points because we're not going to be able to plot anything closer than that. So we got the center, we've got A and B. We can sketch it, then we'll come back and figure out what the values are. Again, we can fit this in our normal scale. I'll make sure you don't have to worry about the scale. Just make it from -10 to +10. First thing, plot the center. It's a vertical transverse axis, so this goes in the vertical direction. So we go 1, 2, 3, 4, 1, 2, 3, 4, symmetric around the center. Then we have B, which is 2. B goes the other way. So you go -2, +2. And because this is the vertical transverse axis, we go up. These are always aligned. So we go 4.5 and -4.5. And then we can draw our little box. And then we can draw some diagonals through there. Okay. Now we'll draw the hyperbola in just a second. Let's go back and figure out what we got here. So we have the center, vertices. Okay, so we can see that the vertices are at a particular x coordinate, which is going to be 0. And here we go down 4, 1, 2, 3, 4, so it's -4. And we go up 4, which is +4. So the vertices, the foci, are also at x equals 0. But instead of going down 4, we go down 4.5. And we go up 4.5. Now the equation, now this is a vertical transverse axis. So we go to the book again, or your notes, and we say y is equal to k plus or minus a over b times x minus h. So again, k and h are 0. So you get y is equal to plus or minus a is 4, b is 2, x, h is 0. So we get plus or minus 2x. So that's the equation for the asymptotes. And again, you could go over here, start at the origin. So there's the y-intercept is 0, and the slope is +2 + 1. So it's 2 for this line, has a slope of 2. And then this one has a slope of -2. So it's down 2 over 1. So you could get that off the graph as well. And finally, we're going to draw the hyperbola. Because we're aligned here with the y-axis, the vertical direction, it's going to go like that, and it's going to go like that, and then you come down here. Again, you go through the vertices, not the foci. The foci are to determine the two lengths. So again, reviewing what a hyperbola is, you go from the focal point here to the hyperbola over to the other focal point. And the difference between this length and that one, so this minus that, is a constant for the hyperbola. Okay, next one. So this one is, this one got messed up because I moved everything down a little bit. Now here we're not going to have, we're going to have numbers that are not whole numbers, but the procedure's the same. So the first thing is it a vertical transverse axis or horizontal? So the y is the positive, so it's going to be vertical. This is number 3. Vertical transverse axis. The center now is not the origin. Now, the number associated with the x term is x minus, well, it's x minus h. So in this case, it's h is equal to -3, and here you have y minus k, so k is equal to 2. So that's the center. A always goes with the axis, the transverse axis. So A is the y associated with the y term. So 17 is a squared, so a is equal to the square root of 17, and b is equal to the square root of 24, and we'll just convert those to decimals. So you get 17 square root 4.1, and b square root of 24 is 4.9. And then we can get c. So c squared is equal to a squared plus b squared. So that's 41. Add these together, 41. So c is equal to the square root of 41. And CO is always greater than either a or b for a hyperbola. So you get 6.4. Okay, so that with that information we can plot things. So first step is plot the center, -3, 2. So there's my center. Then it's a vertical transverse axis, so I'm going to go up 4.1. 1, 2, 3, 4. 4.1. I'm going to go down 4.1. 1, 2, 3, 4.1. Because it's a vertical transverse axis, C is along the same axis, so I go 1, 2, 3, 4, 5, 6.4, down 6, 1, 2, 3, 4, 5, 6, 6.4, and then the other way I go B units 4.9, so 1, 2, 3, 4.9, that's about right there, 1, 2, 3, 4.9. Draw my box. So it'll be a little tricky because these points are not on the grid. And I'm going to move these just a little bit so that they're at least representative. So this one's just a little bit above there, a little bit above the grid. So it's 4.1. This one is a little bit to the right, and this one's a little bit to the right because I'm going 1, 2, 3, 4.9. So this one's a little bit to the left and right, whereas these are a little bit inside. Same thing here. This is going to move up. So it's close to this line, but not exactly. And then we can draw that, which already leads me to believe we got a problem. So that's probably a good thing that we did that. So let's see what went wrong here. So we got -3, 2. Okay, that's right. And the B is 4.9. 1, 2, 3, 4, 4.9. 1, 2, 3, 4. Okay, I didn't go far enough. Gotta go over here, 4.9. Move that over. Extend these. Okay, now, if I've done this correctly, this should go through the center point. This one should go through the center point. So that you do, so that's good. Now, as far as sketching this, start at the vertex, go over here, approach the asymptote, go the other way. Try to be as symmetric as possible within your drawing skills. Okay, so there we go. So let's go back over and figure everything out. So vertices. So you can see that all of these things, the foci and the vertices, are along this line, which is -3. So we'll put -3 here for all of them actually. We're just doing it now to make sure we're consistent. Now, going up here, we're at 2, right? 1, 2, 3, 4, 5, 6, 6.1, because I'm going up 4.1. So you're at 2 and you go up 4.1 more, that's 6.1. So I'm going to put that second because that's the larger one. 6.1. If I go the other direction, 4, 1, 2, 3, 4, 4.1. So that's going to be negative 2.1. So we go from negative 2.1 up to 6.1. Again, if you subtract this, you'll get 8.2, and half of 8.2 is 4.1. Now for the foci, it's the same kind of deal, except I'm going up 6.4. So 2, 3, 4, 5, 6. Sorry, 2. So it's 1, 2, 3, 4, 5, 6, 6.4. So that's 8. There's 8, 8.4. So that's the second one here. 8.4, and then we go down. 1, 2, 3, 4, 5, 6, 6.4. So that's going to be from the axis is 1, 2, 3, 4, 4.4. Negative 4.4. So it's negative 3 to negative 4.4. Again, if I subtract this from that, I'll get 8.4 plus 4.4 is 12.8. Half of 12.8 is 4.9. And is that it? I've already sketched it. Equations for the asymptote. Okay, yeah, forgot about those. And this one's a little more difficult. Probably the equation is probably the best way to go. So we have a vertical transverse axis. So we go look equation we need to use. That's y is equal to k plus or minus a over b times x minus h. So what do we know? We know h equals negative 3, k is equal to 2. That's from the coordinates of the center. A is equal to the square root of 17. B is equal to the square root of 24. So we get y is equal to k plus or minus the square root of 17 over the square root of 24 times x minus a negative 3. So that becomes y is equal to 2 plus or minus the square root of 17 over 24 times x plus 3. And this x plus 3 here should match wherever I was over here. Right there, x plus 3. So the one that's looking at these diagonal lines, this is the plus slope and this is the negative slope. Okay, first 3 problems. Now we're moving on to the 4th problem. So this one actually is a little easier because I don't have any weird numbers, meaning square roots, not perfect squares. Okay, so here we go. Horizontal or vertical transverse axis. So it's, well, let's do the center first. Center is 2, comma, negative 1 from these. A goes with the horizontal number, so it is a, so we'll write that out now. Horizontal transverse axis. So that means A is the square root of 25, which is 5, and B is equal to the square root of 16, which is 4. And c squared equals a squared plus b squared. So that's 25 plus 16, which equals 41. So c is equal to the square root of 41, which we did in an earlier problem. So we get 6.4. Must have been the last problem. No, it couldn't have been the last problem. I don't know what. Anyway, 6.4. Okay, so we can plot now. Again, use the standard scaling on this graph. 10, 10, minus 10, minus 10. Okay, plot the center. 2, -1. It's a horizontal transverse axis, so we're going to go 5 in the x direction. 1, 2, 3, 4, 5. And 5 in the other direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Along that same axis, we have C, which is 6.4. 1, 2, 3, 4, 5, 6. 6.4. And 1, 2, 3, 4, 5, 6. 6.4. So those are the focal points. Then we'll go the vertical direction to do B. 1, 2, 3, 4. 1, 2, 3, 4. Let's draw our rectangle connecting those points, which are nice because they're right on the grid. Once you've got this box drawn, then you can draw your diagonals. So we'll start at this one. If I drew this correctly, it should go right through the center, which it does. Same way here. It should go through the center. And we feel comfortable with that. We'll extend them on. So because our focal point is along this axis, the horizontal axis, the hyperbola is going to go this direction, and this one's going to go that direction like that. And now we can figure out the coordinates of everything. So we got the center. We said that was 2, -1. The vertices. Okay, so either the x is going to be the constant for all of these things, or the y. So let's see what these guys are on. So they're all in this horizontal line, and it's -1. So that's y. Y is this vertical distance. So they're all -1, which is the same y coordinate as the center. Okay, so the leftmost vertex is here. We start at the center, 1, 2, 3, 4, 5. So relative to the y-axis, we go 1, 2, 3. So it's going to be -3. And here we're starting at 2. So we go 2, 3, 4, 5, 6, 7. So that's 7. Again, 7 minus a -3 is 10. 10 divided by 2 is 5. And then in the y direction, we start at -1, and we go up. We go down 4. So -1, -2, -3, -4, -5. And that's -5, and then we go up. So we're -1, 0, 1, 2, 3. So it's 3. 3 minus -5 is 8. 8 divided by 2 is 4. So we got that. And then finally the asymptotes. So again, we look at the equation for a horizontal transverse axis. So for a horizontal transverse axis, the equation is y is equal to k plus or minus b over a times x minus h. So we have everything. So we'll just look them up. Y equals k. K is -1. -1 plus or minus b. B is 4 over a, which is 5, times x minus h, and h is 2. And this x minus 2 here should match up with right here, x minus 2. And this -1, this 1 here, when you move to the other side, becomes positive, -1, and that should go along with this this number here. And if you look at the slope, it's 4/5, so you start here and you go up 1, 2, 3, 4, and then over 5, 1, 2, 3, 4, 5. So that's a slope of 4/5. and this one slope with negative 4/5. So that's the equation for the two asymptotes. Okay, so these are all the ones that are already in standard form. So now we're going to have some that we have to convert to standard form, and then you just continue on with the same procedure. And I made some of these up. Actually, I think I made them all up, so it may not be perfect as far as everything being an integer, or most things being an integer. So this is 5. So we take the two x squared terms, put those together, x terms together. We take the two y terms, put those together. They're not already together. We can move the positive 24 to the other side and make it negative 24. Then if there's a coefficient in front of x squared or y squared, we'll factor that out. Well, the first one is already 1, so we don't have to do anything there. So we do that, leave a space to add the third term. Here we factor out a negative 3. So negative 3 divided by negative 3 is 1, and negative 9 divided by 3 is 3. Positive 3. So we get positive 3y. Yeah, it's going to be a little more challenging because I have an odd number, but that's okay. And that's equal to negative 24. Okay, so we're going to take 4, divide by 2, square that. That's 2 squared, which is 4. So we're going to add 4. And because we're multiplying by nothing except 1, we're really adding 4 to this point. So let's add 4 over here to balance it out. Here we have 3 halves, 3 divided by 2 squared, which you can't simplify, so just multiply it out, and you get 9/4. So we add 9/4 here. But really what we're doing is we're taking negative 3 times 9/4. So that's negative 27/4. So we're really subtracting 27/4 from both sides. Now, what we can do is rewrite these as perfect squares. So we have x plus 2 squared, just use 2 here, minus 3 times y plus 3 halves from here, squared, is equal to, so if we add all that stuff together, what do we have? We have negative 24 plus 4 minus 27/4. So this is negative, well, multiply 24 by 4. We want to get those all in fourths. So you multiply this by 4 and you will get 96/4 plus 16/4 minus 27/4. I'm going to use my calculator here to do the numerator. Negative 96 plus 16 minus 27 is negative 107/4. So this is equal to negative 107/4. Okay. Now, in standard form, this has to equal to 1. So what we would do is we'd multiply by the reciprocal of this. And that way we'd get the negatives would cancel out and the other things would cancel out to be 1. So if we do that, we'll get negative 4 divided by 107 times x plus 2 squared plus 3 from here times, now the negatives cancel out, so it becomes positive 4 divided by 107 times x, y plus 3 halves squared is equal to 1. And what we'll do is we'll take the reciprocal of that, and we'll move the y first so it's in the form. So we get y plus 3/2 squared divided by, instead of 4 over 107, it's 107. Oh, I'm doing this one actually. So it's, instead of, here we have 12 over 107, so it's 107 over 12. And then we have subtraction, and we have x plus 2 squared divided by 107 over 4 equals 1. So at this point, let's just go to decimals. So we've got the center is going to be, well, here with the x, you're going to have x equal to -2, and you're going to have y is equal to -3/2. I'm still leaving this as a fraction, but a and b will do as decimals. So that's the center. Because the negative is with the x, we're going to have a vertical transverse axis. And a is equal to the square root of 107 over 12. So let's just put that in our calculator. 107 divided by 12. Take the square root of that. That's basically 3. It's 2.986. And b is the square root of 107 over 4. So 107 divided by 4, take the square root, you get 5.2. And c squared is equal to a squared plus b squared. So you get c squared is equal to 3, I mean, it's not exactly 3, but it's close to 3. So 3 squared is 9 plus 5.2 squared. So the total is 36.0. So C is approximately, again, because we're rounding stuff off, is approximately 6. So let's plot this. Okay, so the center, -2, -3/2. So there we go. Now it's a vertical transverse axis, so we're going to go vertically to do the vertices. So you're going to go, and this is 3, so we'll round it off to 3. So you go down 3, 1, 2, 3 to about here. You go up 3, 1, 2, 3 to about there. The vertices, I mean the foci are further along, 6, so we go 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. And then to the left and right we go 5.2 units. 1, 2, 3, 4, 5, 5.2, 1, 2, 3, 4, 5.2. And then we're going to draw horizontal lines through these points and vertical lines through those points. It's pretty close. Then we draw our diagonals. And if we drew this right, it should go through the center, which it does, so that's good. Same way here, goes to the center. And you can see we have a vertical transverse axis, so it kind of goes like this, and over here, and it goes down there, and it goes that way, like that. Now, to get the coordinates, they're going to be a little trickier because you've got decimals and stuff. Notice they all have the same x value, which is -2. So let's go ahead and put that in there. So we get the vertices, the foci. So the vertices, you got two coordinate pairs. We said x is -2, so put -2, -2. Here it's -2. Here it's -2. Now the vertex starts here at -1.5, and it goes to approximately +1.5. So that's +3/2 instead of -3/2. Now here you're at -3/2, so you go 1.5, 2.5, 3.5, 4.5. 4.5 is 9. So it's -9/2. And if you subtract this from that, you're going to get 12/2, which is 6, and 1/2 of 6 is 3. So that makes sense. And likewise, here you're going to go up 6 units approximately. So we go 1, 2, 3, 4.5. So that would be 4.5, which is 9/2 in the y direction. And then you go down the same distance. So this is 8. So that's halfway. That's 7.5. 7.5 is going to be 15/2. How did I do? -15/2. That's because 7.5, you multiply 7 times 2, you get 14, plus 1 is 15. So that's 15/2. That's where I got that from. And again, if you subtract this from that, you'll get, because this is a negative, you get 9 plus 15, which is 24. 24 divided by 2 is 12. And 12 divided by 2 gives you 6. And then finally, the equations for the asymptotes. It's a vertical transverse axis, so you look on your formula sheet, it says it's k plus or minus a over b times x minus h. So you get y is equal to k, so we go up to the center. K is -3/2. And then you have plus or minus a. A is 3 divided by b, which is approximately 6, times x minus h. H is -2. So you get y is equal to -3/2 plus or minus 1/2 times x plus 2. So that's the equation for the two asymptotes. And let's just check this out. So we're going to plot the original function. We're not going to put it in standard form. I'm just going to plot it. So the way you do that, let's close this thing. So we put an equation in. So we're going to do the implicit version. And it's going to be x squared. Oh, we need to zoom out before we do this. Let's zoom out. So zoom. So we're going to at least get to 10 on the y-axis. Okay. So we're going to put this implicit equation in here, which is x squared plus 4x, x squared plus 4x minus 3 times y squared minus 9 times y plus 24 equals 0. Just check that. So we're down here. x squared minus 3y. Well, yeah, I rearranged it here, so as long as I did that right, okay. Okay, so I'm going to say okay. So that's what it looks like. How does that compare to what we came up with here? Looks pretty good. And let's plot the two equations here for the lines. So it's going to be negative 3 halves plus 1 half. Okay, so we're going to go to an equation. We're going to do an explicit equation. So that's y equals, and you've got negative 3 halves plus the slope, which is 1 half plus 1 half times x minus or plus plus 2. So that's one of them. And then the other one is another explicit equation, which is negative 3 halves minus 1 half times x plus 2. And we say okay. And you can see that the intersection of those two lines is at negative 2, negative 3 halves. One thing you do notice, which is interesting, based upon what we've been sketching, it doesn't approach the asymptote quite as quickly as I have been indicating. So that's, well, it could be just round off somewhere in my calculations. So that makes me worry a little bit. It almost looks like they're getting a little further apart here, so that would lead me to believe there might be something that's a little bit off. So let's just go back and check it. That's one of the advantages of plotting something. You can see what your errors possibly are. So let's just, I'm going to pause it, and then I'll let you know if I see. Okay, well, I didn't see anything that stood out, so we'll assume I did it correctly. Okay, what I think I'm going to do is change these next two problems to make sure they work out a little bit more easily. So I'll be back shortly. Okay, so now these agree with what you have on your sheet that I've handed out. So let's, in this case, because right now y squared is positive, let's just put that first. And they're already grouped together, so we can go ahead and do the second step since the two terms are grouped together. So we'll factor out a 4 here. So that'll give us y squared minus 8y. Leave some space to do something to complete the square. And we're going to factor out a negative 6 out of the, not negative 6, negative 2. I'm looking at the wrong problem. So we've got negative 2 in front of x squared, so we'll do negative 2. So we'll get we'll get x squared minus 4x by factoring out negative 2. And then we'll move 24 to the other side, so it becomes negative 24. Okay, so let's take negative 8 divided by 2. I'm going to square that. That's negative 4 squared, which is 16. So we add 16. Well, really, we're adding 16 times 4, which is 64. So I'm adding 64 here, so I need to add 64 here. Here I have negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2 squared is equal to 4. So add 4, but I'm really subtracting 8 because I'm taking negative 2 times 4. It's negative 8. So I'm going to subtract 8. So now this can be rewritten as 4 times x minus 4 squared minus 2 times x minus 2 squared. And if I do the right hand side, I get negative 24 plus 64 minus 8, and I get 32. Now I need a 1 on the right hand side, so I'm going to divide everything by 32. Like that. And then I'm going to do this reciprocal thing. So I get y minus 4 squared over 32 divided by 4 minus x minus 2 squared divided by 32 divided by 2. So this goes down there. This equals 1. But 32 divided by 4 is 8. And 32 divided by 2 is 16. And that equals 1. So that's the standard form. So I did do it right when I was putting this thing together. So what can we say here? We can say the center is at 2, 4. 2, 4. We know that a squared is equal to 8. That always goes with the, yeah, so before we do that, we have to make this comment about, it's going to be vertical, transverse axis. So we get a is equal to the square root of 8, and b is equal to the square root of 16, which is 4. So a is square root of 8, which is 2.8. And c squared is equal to a squared plus b squared. So that's 8 plus 16, which is 24. So c is equal to the square root of 24. So 24 square root, it's 4.9. Okay, so now we are going to put our graph in here. Okay. Yeah, these take a long time. I'm getting tired too, so I sympathize with you. Okay, x, so we're going to go standard scale here. Center, 2, 4. There you go. We have a vertical transverse axis, and a is 2.8. So we go up 1 to 2.8 and down to 0.8 right there. The focal points are 4.9, so we go 1, 2, 3, 4, 4.9, down 4, 1, 2, 3, 4, 4.9, so that's there. And then we go the opposite direction. For b, b's 4, 1, 2, 3, 4, 1, 2, 3, 4. We draw this box, which I haven't got quite in the right place yet, but I will in a second. Just don't get too excited about that I'm not lining these up correctly, because I'm going to do it in a second. So I'll move that up to there. Shorten that thing a little bit. Shorten this a little bit. Shorten that a little bit. Okay, same up here. I can move this down. Scale them a little bit. Okay. So there's my box. This one looks like I need to move for a little bit. And if I drew this correctly, of course, you've seen me do this before. Draw a line diagonal. Should go through the center. This one should go through the center. Extend these out. Like that. And then it's going to look something like that. Same here. So there we go. So let's now find the coordinates. Now notice everything's along this vertical line. So let's go ahead and fill those out before we move on. So that's x equals 2. So it's going to be 2 comma something, 2 comma something, 2 comma something, 2 comma something. Now here we start at 1, 1, 2, 3, 4. That's because the center is at y equals 4. And then we move up another 2.8. So 4 plus 2.8 is 6.8. And 4 minus 2.8 is 1.2. So this is 4 plus 2.8. And this is 4 minus 2.8. Now with the focal points, this is going to be 4 plus 4.9, which is going to be 8.9. And you're going to have 4 minus 4.9, which is going to be negative 0.9. And you can see here, this one's negative 0.9. This one's positive 8.9. So those agree with everything we need. Okay. Number 7. So again, we're going to put this in standard form. Notice the x squared is positive. And they're not in the right order yet, so we're going to group the 20x with the 5x squared. We'll take the negative 6y squared and group it with the negative 24y. And we'll go ahead and move 34 to the other side. Negative 34, so it becomes positive 34. We factor out a 5, so we get x squared plus 4x. Leave some space. Factor out a negative 6. We get y squared plus 4y. Leave some space. Leave the right-hand side alone. Okay, just look at it, double check, make sure everything looks good, which it does. So you get 4 divided by 2. That's the 4 squared. That's 2 divided by 2 squared, which is 4. So we add 4 here, but we're really adding 5 times 4. So we're going to add 20. Here we have 4 again. 4 divided by 2 is 2. 2 squared is 4, so we add 4. But we're really subtracting 24. So subtract 24. And if you do that, you'll get 30 here. So the final, not the final, almost final, you get 5 times x plus 2 squared minus 6 times x plus 2, y plus 2 squared is equal to 30. And if you divide everything by 30, you get that. And then we can take the reciprocal. So you get 30 over 5 here. And here we get 30 over 6. And finally, you can simplify these. So you get x plus 2 squared over 6 plus minus y plus 2 squared over 5 equals 1. So from that, we can find a and b and see a and b and h and k. So the center is negative 2 comma negative 2. A is equal to the square root of 6 and b is equal to the square root of 5. This is a horizontal transverse axis because x squared is positive to get a positive 1 on the right hand side. C squared is equal to 6 plus 5. because this is a squared, b squared, that's 11. So c equals the square root of 11. So you get 3.3. So let's plot it. Go plot the center. -2, -2. There it is. Plot a. A to the square root of 6, so we need to figure out what that is. What's the decimal? Square root of 6. It's going to be 2.4. And b is the square root of 5, which is going to be a little bit less, which is 2.2. Okay, so it's a horizontal transverse axis, so I'm going to go to the right 2.4, I'm going to go to the left 2.4. Because it's a horizontal transverse axis, I can use now, put in the foci, so I go 1, 2, 3, 3.3, 1, 2, 3.3, so that's my focal points. Then I go in the other direction, 2.2 units, 1, 2, 2.2, down 2.2, here we go. So we draw a horizontal line here and draw another horizontal line there. Draw a vertical line here. Draw another vertical line here. Got carried away, didn't I? Okay, let's do some aligning. Okay, that's pretty good. Okay, we're going to draw our diagonal line, which should go through the center. So that's good. It's encouraging. Okay. And then you draw it like this. Okay. Finally, notice everything's along a constant y line here, which is -2. So the vertices and the foci are going to have y equals -2. Okay, so let's do the one that's to the left. So you go -2, and then a is 2.4. So it's -2, so that's -4.4 up here, -4.4. And here we are at 2, so that's 2, so we have an additional 0.4, so that's positive 0.4. You add these, subtract, so 0.4 minus a -4.4 is 4.8. 4.8 divided by 2 is 2.4. Okay, then the focal points, you're going to go 3.3. So you start at 3, go, at 2, -2, -3, -4, -5, -5.3. And then you go the other direction, so it's 1, 2, that's 0, 3, 3.3, so that's 1, 1.3. 1.3 minus a -5.3 is going to be 6.6. 6.6 divided by 2 is 3.3. And then the equations for the, I think I forgot to do that on the last problem. But again, you look at horizontal transverse axis. So the equation there is y is equal to k plus or minus b over a times x minus h. So k was -2 plus or minus b, which is 2.2, divided by a, which is 2.4, times x minus h, which is negative 2. So you get y is equal to negative 2. Let's just carry that out. 2.2 divided by 2.4. So that's plus or minus 0.92 times x plus 2. So those are the equations for the asymptotes. Okay, so now we're going to move on to the next section. So what we have to do is come up with a standard form based on this information. And these are centered around the origin, so they shouldn't be too hard. So again, the best thing to do is to plot these points. Think about what's going on. So you've got the vertices, which are plus or minus 4x. And if you see, the midpoint is the origin, so that makes sense. The focus points are plus or minus 6, so you put those there. So what do we need? Well, we know the center. The center is the origin, because they told us that. But even if they hadn't told us it, we would know it from these coordinates. We know that a squared is equal to 16, because it's 4 units from the center to each one of these focal points. So a is 4, so a squared is 16. We know that c squared equals a squared plus b squared, or b squared is equal to c squared minus a squared. Now, we know that c is equal to 6, so c squared equals 36. So that's 36 minus 16, which is 20. So b squared is 20. Now we don't have to take the square root, because the standard form is going to be equal to, it's x minus h squared. Now this, and it's positive x because we have a horizontal transverse axis, so that's the correct thing, over a squared minus y minus k squared over b squared is equal to 1. Well, h and k are 0 because it's the origin. A squared is 16. A is 4. And then you subtract y squared, and b squared is 20, and that equals 1. So that's the standard form. Okay, let's look at the next one. Now here they give you the asymptote. If I give you one, it'll be like the first one, if I give you that on a test problem. That's probably the most straightforward one, where they give you the vertices and the foci, then you can figure out the center and everything else. So, but we do know that the center is at the origin, because it's given in this problem. And we know the vertices are plus or minus 1 here. And that's in the x direction. So again, this is going to be a horizontal transverse axis. Now it says the asymptote is y equals 5x. So one thing you could do is you could look at the equation for the asymptote. It's going to be equal to k for a horizontal transverse axis. It's going to be k is equal to b over a times x minus h. But for our case, because of the origin, h and k are 0. And so we know that b over a is equal to 5. It's this slope. And we know that a is equal to 1 because the vertices are plus or minus 1 from the origin. So if a is 1, that must mean b is 6. This is b. It's 5. I don't know where I got 6 from, because that looks like a 6, but it's really a b. So you get b over 1 is equal to 5, therefore b has to equal 5. So b squared is equal to 25. And we know that a, from here, a is equal to 1, so a squared is equal to 1. So the equation is going to be x squared over a squared, which is 1, minus y squared over b squared, which is 25, equals 1. So it's going to be real narrow, or it's going to be, kind of off-symmetric hyperbola. Okay, moving on. So the next two are where the center is not the origin, but you can kind of follow the same procedure. You just have to plot the center. In this case, the first one again is the easy one to give you the vertices and the foci. So we know we'll know that you can see they're all 1 for the y. So that's going to be a horizontal transverse axis. Okay, let's spot these points. So we have -2, 1, +2, 1. So those are the vertices, and the focal points are here, -3, 1, and +3, 1. So you see it's a horizontal. From that we can say it's a horizontal transverse axis. And we can see the centers right there. It's going to be right in the midpoint. So we can say the center is 0, 1. Notice the center and all these things have the same y-intercept, have the same y value. So what can we say? Well, we can say that A is the distance from the center to the vertex, so that's 2, and C is the distance from the center to the focal point, which is 3. So that's C. And we know that c squared is equal to a squared plus b squared for hyperbola. So b squared is equal to c squared minus a squared. So that's 9 minus 4. A is 3, a squared is 9. Pardon me, c. C is 3, c squared is 9. A is 2, a squared is 4. So you get 5. So b squared is equal to 5, and b is equal to the square root of 5. Now once you have the center and the a and b, and knowing that it's a horizontal transverse axis, you're going to have x minus the x coordinate of the center, which is 0, squared, divided by a squared, which is a is 2, so a squared is 4. Then you subtract y. The y value is positive 1, so it's going to be y minus 1 squared. And you're going to divide by b squared. B squared is 5. And that equals 1. So you get x squared over 4 minus y minus 1 squared over 5 is equal to 1. That's your standard form. And then finally, the last one. So again, let's plot this thing. Again, this is more difficult than I ended up putting on a test, but I just want you to work with me on this one. So the vertices actually are the same as the last problem. That means the center is the same. So the question is, how do you figure out anything else? Well, we do know it's a horizontal transverse axis because I can draw a line through these points. I also know the center has the coordinates of 0, 1. So from that, I can partially write this. I'm going to have x squared divided by, and the a is 2. It's the distance from the center to the vertices, so it's going to be a squared, which is 4. I'm going to subtract y minus 1 because the y coordinate of the center is 1 squared over b squared, and that's equal to 1. So I just need to figure out b, but I know that it goes through this point, 5, 4, right? So this is 5, 4. So all you have to do is plug 5 in for x and 4 in for y, and you see that the only thing that we don't know is b squared. So we get 25 fourths minus 9 over b squared. So you get 4 minus 1 is 3, 3 squared is 9, equals 1. Let's subtract 25 fourths from both sides. So that's 4 fourths minus 25 fourths. Here we get negative 9 over b squared. So we get negative 9 over b squared is equal to negative 21 over 4. So 4 minus 25 is negative 21. Let's cross multiply. The negatives are going to cancel out. You get 9 times 4 is 36. B squared times 21 is 21b squared. So b squared is equal to 36 over 21. So there's b squared now. So now we can go back to this original equation and replace b squared with what I just calculated to be, which was 36 over 21. And that equals 1. And so you can actually simplify this a little bit. I didn't see it initially, but I checked my answer and I'm correct, except both of these are divisible by 3, so that becomes 12 sevenths. And the book actually shows this, but I would still stick with that. So they have 7 times y minus 1 squared over 12 equals 1. Okay, so that's it. All 1 hour and 18 minutes.